Have you ever wondered if there are other versions of you, living in alternate realities? Let's dive into a captivating hypothesis that dares to answer this question: the multiverse hypothesis. This daring concept suggests that our universe, the one we perceive, the one we inhabit, might not be the only one. In fact, it postulates that there could be an infinite number of universes, each unique, yet bound by the same laws of physics. Imagine a cosmic quilt, where every patch represents a universe. Some might resemble ours, while others could be unimaginably different. This is where the idea of parallel universes comes into play. These are universes where different versions of reality might exist. Perhaps there's a universe where you are the president, or another where dinosaurs never went extinct. Intrigued yet? Pack your ontological luggage, we're going on a journey through time and space. The multiverse hypothesis might sound like a science fiction concept, but its roots are deeply embedded in scientific theory. Emerging from the enigmatic world of quantum mechanics, this idea has challenged our understanding of the cosmos and our place within it. Let's take a step back to the early 20th century when the theory of quantum mechanics was taking shape. At its heart, quantum mechanics is a theory of probabilities. It suggests that particles do not have definite properties until they're measured. Rather, they exist in all possible states simultaneously, a concept known as superposition. Enter Erwin Schrödinger, a key player in the development of quantum mechanics. He famously illustrated this paradox through his thought experiment known as Schrödinger's cat, where a cat in a box could be both alive and dead until observed. Schrödinger's work laid the groundwork for the multiverse hypothesis by suggesting that every possible outcome of an event happens in some universe. A few decades later, physicist Hugh Everett took Schrödinger's ideas a step further. He proposed the many-worlds interpretation of quantum mechanics, where every quantum event spawns new universes. In this view, there's a universe where you decided to wear a different shirt today, another where you chose a different career path, and an infinite number more with every conceivable variation. These ideas were radical and sparked intense debate within the scientific community. However, they also sparked curiosity and opened up a new frontier of possibilities. The multiverse hypothesis challenged the Copernican principle, the idea that there's nothing special about our place in the universe. Suddenly, our universe might just be one of an infinite number of universes, each with its own laws of physics. And thus, the multiverse hypothesis was born, opening up a Pandora's box of questions. It might be a daunting concept to grasp, but it's also a testament to the human spirit of exploration and curiosity, constantly pushing the boundaries of our understanding. The multiverse hypothesis gained momentum with the advent of string theory. This groundbreaking theory revolutionized our understanding of the universe and its composition. So what exactly is string theory, and how does it fit into the multiverse hypothesis? String theory, in a nutshell, is a theoretical framework where the point-like particles of particle physics are replaced by one-dimensional objects called strings. It's like trading in the building blocks we're familiar with for incredibly tiny vibrating strands of energy. These strings vibrate at different frequencies, and these frequencies manifest as different fundamental particles. That's right, according to string theory, everything in our universe, from galaxies to you and me, is composed of these tiny strings. But here's where things get even more interesting. String theory doesn't just stop at describing our universe, it opens up the possibility of countless others. You see, for string theory to work, it requires the existence of more dimensions than the four we're familiar with: 3 dimensions of space, and 1 of time. Some versions of string theory propose up to 10 dimensions. Now, these extra dimensions are not easy to visualize, but they're crucial for the theory to hold water. And it's these extra dimensions that could house other universes or brain worlds. Picture these brain worlds as slices of bread in a cosmic loaf. Each slice could be an entirely different universe with its own laws of physics, coexisting with ours in higher dimensions. This idea of brain worlds coexisting in higher dimensions aligns perfectly with the multiverse hypothesis. Each brain world could represent an alternative universe, part of a vast multiverse. So, in essence, string theory doesn't just allow for the multiverse, it requires it. The string theory, thus, adds another layer of complexity and intrigue to the multiverse hypothesis. It's a fascinating concept that could potentially reshape our understanding of the universe, or should we say multiverse. Our understanding of the multiverse took another leap with the theory of cosmic inflation. Cosmic inflation is a fascinating theory that revolutionized our conception of the universe's birth. It posits that a fraction of a second after the Big Bang, the universe expanded exponentially, faster than the speed of light. This rapid expansion smoothed out the universe, explaining why it appears mostly the same in all directions. But wait, if the universe expanded so rapidly, wouldn't it be infinitely big? Well, that's where things get interesting. According to the theory of cosmic inflation, the universe is indeed infinite, but the part we can observe, our visible universe, is finite. Think of it like being on a boat in the middle of an endless ocean. You can only see so far, but that doesn't mean the ocean ends at your horizon. So how does this tie into the multiverse? In the context of cosmic inflation, the multiverse is a natural consequence. The theory suggests that inflation could have happened multiple times, creating a multitude of universes or bubbles within the larger cosmic sea. Each of these bubbles could have different physical laws, different dimensions, even different versions of reality. Our visible universe then may be just one bubble among an infinite number of others in a grand multiverse. But it's important to note that the multiverse is not a prediction of the inflationary theory, it's a byproduct. It's an idea that springs from the mathematics and the principles of the theory, and while it's a tantalizing concept, it's also a controversial one. Some scientists argue that without empirical evidence, the multiverse remains in the realm of speculation. Yet the idea of a multiverse born out of cosmic inflation has opened up a whole new avenue of exploration, pushing the boundaries of our understanding of the cosmos. It invites us to consider the possibility that our universe may not be the only game in town, but rather, just a tiny part of a much larger, much stranger cosmic arena. Cosmic inflation, therefore, offers a tantalizing glimpse into the vastness of the multiverse. So, where do we stand today with the multiverse hypothesis? Let's dive right into it. Currently, the multiverse hypothesis sits at the center of a hotbed of debates and controversies within the scientific community. This is largely due to the fact that it's an idea that's both thrilling and unnerving in equal measure. It's thrilling because it opens up the possibility of countless universes, each with its own unique laws of physics. It's unnerving because, well, it's almost impossible to test or validate. That's right, one of the key challenges in the multiverse hypothesis is its testability. Many scientists argue that if we can't observe or measure these other universes, then the hypothesis is untestable and therefore not a scientific theory. It's a bit like trying to prove the existence of a ghost. If you can't see it, touch it, or measure it, how do you know it's really there? However, this hasn't stopped scientists from exploring the idea further. In fact, there's ongoing research looking into ways we could potentially detect the effects of other universes. For example, some physicists suggest that if our universe has collided with another in the past, it might have left an imprint in the cosmic microwave background radiation that we could detect. What does this mean for our understanding of the universe? Well, if the multiverse hypothesis were to be proven true, it would fundamentally change how we view our universe. It would mean that our universe is just one of many, and the laws of physics we know might not apply everywhere. But for now, the multiverse hypothesis remains in the realm of speculation and theory. It's a captivating idea, one that has inspired countless science fiction stories and movies. Yet, it's also a deeply controversial one that continues to divide the scientific community. The multiverse hypothesis remains one of the most fascinating and controversial ideas in modern physics. So, what have we learned about the multiverse hypothesis? The concept, born from the intricate dance between quantum mechanics and general relativity, suggests that our universe may not be the only one. It may exist as one of countless others, each with its own laws of physics. The multiverse hypothesis has found common ground with string theory, a framework that envisions tiny vibrating strings as the fundamental building blocks of all matter. When we touched on cosmic inflation, we saw how it could potentially give birth to multiple universes, thus supporting the multiverse hypothesis. And today, the hypothesis stands at the forefront of cosmology, a subject of intense debate and study. The journey through the multiverse hypothesis has been a ride through the cosmos, from the tiniest strings to the vast expanse of potential universes. As we delve deeper into the mysteries of the universe, who knows what other fascinating ideas we might uncover? Until then, keep exploring, keep questioning, and remember, the universe is full of possibilities.